So this is a frequency modulation lab work. This is a P06 in our, and this is P08 by the name, okay. But this is in fact FM lab work. This is this lab work, and let's look what have to be done there. It's really simple, yes. Okay, new share, we go here. Let's look what is inside this lab work. This is also automatic translation. Must be fixed someone once when I will have more time. So you will create FM receiver based on the ready block. This VB FM receive block. This is block. This is here, yes, which will be used. This is a block which has this FM demodulator and everything inside. This is like in Simulink we have used in the first lab work. So it is the same what we did in the first lab work, but only in GNU radio. You see, this is the same, approximately the same number of blocks, and the whole, it looks very, very similar to what we have done in the first lab work. Here you can even see the parameters, which is much better than in Simulink. And here, this is either you can use VX or QT. Here is the Pluto SDR, wideband FM, rational resampler, which is resampling just from 1 megahertz to 48 kilohertz. So this is like (40 times 48 times interpolation and 100 times decimation). So we go to 48 kilohertz and go to audio. Since this multiply const is in fact also not necessary. Very simple. This is much simpler than you can find in the internet. Yes, this is like simplified and straightened version. The next thing which we will do in this lab work, we will create FM demodulator, this unit, on our own. We will use delay, complex conjugate, and multiply block. Yes, and then phase extractor. This is all 1, 2, 3, 4 blocks. Delay, complex conjugate, multiply. They will replace this VBFM receiver demodulator, and the rest will be the same as in previous model. We just, but this is also, you see, this is QT and this is VX. This is a little bit inconsistent. By the way, you can also leave with VX both or both QT, that you will not have to rebuild. After that, we will do the same thing in the Simulink to compare performance in the Simulink and GNU radio. Yes, and that's it. This is like 3 tasks which we do during 2 lectures on the next week. Of course, maybe it will require a lot of time for some people, but for me it will not take very much time. So I will now demonstrate a little bit very fast because I do not have much time, and also that's why, because next week we will have 2 pairs. This is will be already overload for us, because this course is not, this is like 3 credit course in which we have just 2 lectures each second week, and it is also paid appropriately, of course, and I'm not going to spend a lot of time on it, really. Okay. So I will connect this SDR. Just maybe I will disconnect it from, okay, I will disconnect my iPad, connect this one. Okay, this is working, very nice. Maybe I will need better antenna because we are... Sorry?
Can we turn off this computer? It's making a lot of noise.
What means lot of noise?
It's like you will tap onto this computer, like to go to make the noise go.
Ah, but this is a computer, I think, no?
Yes. Can we turn it off?
Oh, yes, I think then you switch it off. Shut down this computer because we have enough computers. And I will, okay, this person which were fixing it, now it's dismissed due to the absence of the certificate, so it will be problem to fix it. Okay, I will find some cable for the antenna because I'm on the countryside and I will need...
It's not getting turned off.
Why? It will take time, like 2 minutes approximately. You should wait.
I press the power button, still it's not.
But what happens?
We can't see the screen. The monitor is not getting turned on.
Okay, okay, do not touch it for maybe 5 minutes. It will shut down.
Okay. But we can't hear you because of this noise.
Okay, it was silent before.
Yes.
But I can hear you perfectly. Very strange, isn't it? I cannot hear this noise at all because I think I have noise suppression into the Zoom, but you do not have in your head, yes? Okay, I will connect some antenna here because I'm on the countryside and this is maybe difficult to receive. Okay, now I will switch to the radio. If you wish, you can follow me, but I will be working quite fast. Okay, now I'm on this. This is a GNU Radio companion, but this is some other model. I just create new. And I will use Qt GUI because this is much more, because VX is not supported in newer versions, and that's why I will prefer work with the Qt GUI. Maybe I will extend a little bit this window. I'm working from the Macintosh. Hopefully it will not crash because this is not really native GNU Radio. So if you launch GNU Radio, this is like you run this GNU Radio and this is this orange icon and you will launch this, and we did this last time. So this is options, you select Qt GUI. I recommend this, but you can use VX, but this is your This is even C++ supported. Very cool. So sample rate, this is variable which is not necessary, but okay, maybe I will, because this sample rate is used a lot in many blocks, I will leave it, but I will put it to 48 kilohertz because it will be my sound card sample rate. First thing which I do, I have to find, okay, I will save the model first of all, just somewhere. Okay. Projects, because I have already made of a lot of those. You see, this is like, but okay, I will call this P06 FM GRC. Okay, this is not here. P06 FM. Maybe I will add the date 21/11/30. Save. So, first of all, I find the Pluto here. And what I see is that there is no. And this is really interesting that this is not supported. Okay, you use Pluto, but I think I have to use SOPI source because you use Pluto SDR, but I think under Macintosh, I do not have this driver. I will use Pluto SDR driver from the SOPI library. This is a sampling rate which is necessary for the baseband. And I have to create new variable. Here, which will be representing this baseband sample rate. I will call it baseband rate. And here I will use it for the sample rate. Just maybe output type complex float 32. It's okay. So you use, I think, Pluto SDR source in this place. Now I will find some block for the VBWFM. This is the demodulator, WFM receiver. Okay, it will be connected to the source. Then after that, we will need rational resampler to go from this baseband rate to the sample rate. Okay, but not fractional, but rational. Okay, but this is, I just search for resampler. Okay, and here, because baseband rate must be like, okay, I will use 240 kilohertz here. So when here, that means that I have interpolate 1 and decimate this baseband rate divided by samp rate. This is a 5 times, actually. You can also write 5 here if you wish, but more correctly is to write some kind of expression here because it will be more flexible. Connect it here. Okay, data type, because output, the quadrature rate will be baseband rate. And here we have also audio decimation. That means that theoretically you can decimate here and even do not have this resampler, but maybe we will not do this. And this is the output data type. It's because it's complex. I need also complex here. Orange, I pressed the button up and connecting is pressing on the input and the output. Okay, it shows something red because it doesn't like something. Because it's not integer, because it's dividing two floats and getting non-integer. So I have to write, I think, int like this. So it just converts to integer. And now it seems okay. After that, we will go just to the audio sync and playback. So I just say audio sync. This is a speaker. And here I connect to the speaker. And theoretically, that's it. It must be working. I will save. And God bless us. We will try to run it. Okay, there is some problem. Source. Has some bug, I think. Model SOPI has no attribute source. Has very strange bug. Okay.
I am also getting an error. That's name.
So it works?
No, error. It's showing expression is invalid for type integer.
Where?
In the SBR source.
Okay, then that means you have to put some floating number instead of integer, because this GNU radio is very sensitive. Do not put any numbers like with E something or because they will be treated like floating point numbers. You should type really integer in with many zeros, for example, or you should type int in the and in the brackets all these expressions that it will convert to int even.
Yeah, now it's okay because I write 240 E3.
Okay, you see I have a lot of models already. Let's I open SOAP model which is already created before. Okay, that means that there is some bug into SOAP module because after upgrade.
Now it's working.
Okay, but me it's not working. Okay, let's try. I will now try. I have several GNU radios. I will try to use another one. Running via some called Mac ports. Library.
Professor, I can't see your screen again. Screen.
Okay, I have switched off because it doesn't work. I switched to another software. Okay, I will try now. Okay.
Okay.
Okay, I will now share the screen back to my. Okay, now I think I have found another. I have several GNU radios. This doesn't have this SOAP, but it has original block which you have, this Pluto SDR. And it is much better, by the way. So here, I just saying local oscillator frequency. This is which frequency you are tuning in. Yes. Here, it's better. Let's add some random frequency. Let's say 100 megahertz. If I type like this, it will have message that it doesn't support because Pluto doesn't support floating point frequencies. So I have to put int in front here, and then it converts anything to integer. Sample rate must be here. It is baseband rate. RF bandwidth is okay. Buffer size okay. This is like gain. It's manual, but we could use slow attack, automatic gain, and then save. Let's try to, okay, it's some problem. Okay, sample rate must be at least. Okay, it doesn't allow you 500, less than 520 kilohertz. That means I cannot use 240. I have to use 240 times 3. This is 720. Okay. So I change baseband rate to 720. It must be multiple or of 48. This is important. Yes, otherwise your resampler will have problems. Okay, that's working. Okay. Okay, fractional bandwidth. Okay, it must be something larger. Okay. It looks suspicious, but okay. Okay, it has launched. It is good sign, yes. So it is biggest troubles are over. So because biggest risks that Pluto SDR will not work, and then it's a hardware driver, and this is lot of problems. If this works, okay, now we will do the rest. First, which we will do, we will add some slider to get some functionality of tuning on the frequencies, yes? So I go and find the slider. Okay, it will be range widget, yes. It's a QT, the slider is called QT GUI range. This is a slider, in fact, and here we will change the frequency. So we will change from default value will be 100 megahertz, but our tuning range will be from 90, because FM band, commercial FM band starts at 90 in Latvia and ends approximately at 110 megahertz. So it will be our tuning range, counter plus slider, and this must be integer. Okay, and here, this I will call carrier frequency, like I will call, for example, FC, yes? And then I will use this FC inside this Pluto here, yes? Instead of fixed frequency. So when I will move the slider, it will change the frequency of the Pluto. Another thing which I will do, I will add spectrum analyzer to have better control and better easy tuning, because I will see some peaks in the spectrum and it will allow me easily change to the station. So I have sample rate through 720, so I efficiently will see like 300 megahertz. So it will be like one station. I'm in deep countryside, so I think I have only one radio station, about 90 megahertz here, which I can receive. So hopefully I will be able to receive. I'm 100 kilometers from Riga now. And okay, now I will add spectrum analyzer. For this, I go to instrumentation here and go to QT, and here I get like FFT sync or something like this. Frequency sync, yes, okay. And I have to connect it immediately after the Pluto. So I have version 3.8.4. This is like quite modern version, copyright 2021. So I think you have older versions. Could you go to this help about and say which version do you have?
.7.11.
Okay, this is old one, because there is huge difference between 3.7 and 3.8. Even it visually look a little bit different. Okay, but mostly the logic is the same. It's not like in MATLAB, they change total layout in some version. Okay. Now I will try to run. Now I will see slider and spectrum. You will see it will be not.
We can't see the spectrum.
Totally empty spectrum. So there is some data communication system. Hey, do you see my tuning window? I think you do not see it.
No,
I think my window is here, yes? Oh, you see, there is some station here. It has a lot of, it is quite weak. This is like 92.38. So in fact, we can move with 200 kilohertz step because stations are just, I'm even thinking that if I go to this slider, I maybe could change the step. Instead of 1 hertz, I could change 200 kilohertz. So I will just jump between the actual channels, and it will be much more easier to tune, I think. Because all the stations in Latvia are going with a step 200 kilohertz. And hopefully the start is 90,000. But okay, there is a 5 stations per 1 megahertz. Do you receive anything in your model?
no, but we can't hear because we are not using headphones.
Because in Riga, there shouldn't be a problem. My car radio still receives here most of the stations, but it has great antennas and some kind of amplifier. The antennas are close to window. You see, there is some station here. This is quite weak. Another solution would be put huge sample rate here, and then we will see a lot of frequencies. Like, for example, we can use like 4800. This is 4 megahertz, but I don't know if it will support it. And maybe, yes, you see, but this is the computer is not able to handle it such high speed USB data. That's why we see those views.
So we can't hear you.
It's under. There is one station, you see the speed. This is at .4. But no other peaks. You see the spectrum quite flat. So in fact, to avoid this, I think the best is to use as small as possible. So like if we have 48, so 48 times 5, 10 is 480. I think if I just say some, okay, let's go back to 720, but even you can use smaller values because lowest was 520. That means this is like 48 times 11 or something like this. So this is like, this is 528,000. And then the decimation will be 11. And this is lowest possible frequency. Okay, then I go to 92.4. I think I have only one station here. And it works. Maybe you can even hear the sound. Yes, this is a Kurzemes radio, which is only station in this region. Have you receiving anything? Still.
Actually, we don't have headphones.
Okay, but maybe you do not have headphones, yes?
And I
This is a
didn't follow
problem.
the full step because
I can hear the sound throw, sir. But
Naveen, do you receive?
yeah, I can hear the sound. Yes.
Okay, great. So you use remote connection to the class, yes? Okay, good. So this is the first part. We finished. Okay, let's go with the next. Now what we will do, we replace this ready-made model, ready-made demodulator by some handmade one. So I will just maybe file save as a new name, like FM discriminator. And what I do, I remove this block. Yeah. Maybe a little bit make a space because we will need. So it will look, if you go to the description, what we need delay block. Then we will need complex conjugate. Okay, if you press enter, it's already inserts a block. Then we will need multiplier. Then we will need, okay. Okay, it goes here, here. Then from here it goes here, here. After that, you go to the magnitude phase. I just type phase. And this is complex to magnitude phase. And this is unlike MATLAB, you cannot remove this phase, you have to remove one of these outputs. So I just need terminator, some null thing, so called to terminate this magnitude because it's not used. And it must be of correct type. Orange, just pressing button up. I will select orange. This is a floating real. And phase must just go to the resampler. And that's it, yes. Yes, this is our handmade FM demodulator. So it has this is so-called complex discriminator demodulator. So I will just save and run. Unfortunately, because of very weak signal, we will not very well see all the spectrum components. Okay, even you see this is very quiet. It looks very suspicious, by the way. Let's check. There is no parameters. Oh, delay is not, delay must be one sample. If delay is 0, of course, it will just erase everything. Okay, that's what's reason why it was totally silent. Okay, now it's okay, you hear noise. Fortunately, because I'm not in Riga, I can't distinguish. But in reality, if I were in Riga, some peak with 80 kilohertz for this stereo decoder area, so-called, and we will also see RDS channel for data. Maybe if I go to the Pluto and I change attenuation, just manual and say very big gain, 64, maybe it would work better, but let's check. Okay, and I also will do, I will put this frequency for the slider to my favorite station already. This is 92.4. Save. To not. What's that? Manual. But then fair to the people, everything is one that's very nice. Go either in here, everything. Because I think our layout is automatic. Have some way to manually. This frequency, if I'm not correct, like so this is 32 kilohertz, must be like 100. But wait and wait. Okay, but then this, so I think I can fix it if I go and say here, okay, this bandwidth is incorrect because it's not sample rate, but base band rate. Now I think it will be fine. It's like it's the bandwidth of the radio. This is the central frequency where the radio station. So the radio station is like 50 kilohertz. But in reality, at 18 kilohertz, somewhere we have this carrier over the stereo decoder. You are in mode like this is the key. And then there is another section responsible for the stereo, for the difference between left and right hand for the stereo. Now, of course, we are not decoding the stereo, we are decoding lower The idea is to do the same also in Simulink. Yes. Okay, now I stop new radio, go out from here. Okay, I just save and quit. And now I will need the Simulink. I will run the MATLAB. For this, I will use another computer because it's much more faster. Just a moment. Let's boot.
Spain model. Spain. He said he's going to go to Spain.
Okay, now we will just connect here and I will share. Share. Okay, this is my another computer. Unfortunately, I cannot run GNU Radio on it, but at least for MATLAB, I will use it. All nasty stuff. Trying to launch, we will stop it. MATLAB runs really fast compared to my local machine. It will be like day and night. Okay, now I go to the new Simulink model. And I also will start with the model. Okay, let's use blank model, not a big deal. And now you can feel the difference, yes, between those two systems. It's much more. This GNU Radio is really simple. This is a lot of buttons, lot of everything. Like, okay, this is it gives professionals some kind of professional, of course, but well, this is much more difficult to operate. So I will just go to the regular thing. I just switch off all these things related to stepping. Just go to the single fixed step, no continuous states. Okay. Simulation time must be switched to infinity. Okay, but it doesn't allow you to change unless you do anything. So here I will go to the library and find also Pluto, which we have installed. It's a Russian keyboard. Pluto receiver, which is also necessary. In this case, I will configure it. I will use fixed frequency because now I know the frequency of the radio station. It is 92.4 megahertz. You can use, and also I use dialogue, and here gain will be 64 dB. But you should use maybe slider or anything, but I will not use because I need to do it fast. This baseband sample rate, let's use the same. It will be 528. Kilohertz. And we also use some kind of variable here. Instead of using this, I could put some variable called baseband rate, but of course it's not yet defined. So I can define it here in the workspace. Now theoretically, it should become calm. Okay, I have to reswitch this to this new computer. Okay, it installed.
So what should be the sender frequency?
As you wish, your favorite radio station. And you can put also some kind of slider which controls it, as in first laboratory work. Okay, but okay, let's do everything. So I will just use okay, don't switch off overlap port. Output data type will be single. Samples per frame. Okay, let's leave 20,000, no problem. Okay, I will save it. I will go and save it as on desktop, models, and this is P08 FM. Discriminator. Okay, so some random name. And what we will need here actually is the same blocks. We will need delay, we will need complex conjugate, this is just math function, or this block also could be fine. So if you remember, we went from here to conjugate, then we multiplied those together. Just go and find multiplier. This is a product block, I think, in MATLAB. And then we extract angle, like this is complex to magnitude phase. Just search for magnet. This is complex to magnitude angle. And in this case, we have possibility to select only angle. That means we do not need terminator for the magnitude as in GNU radio. And we just put some resampler. But it's called, I think, decimation. I think it's sample rate converter or something like this. We used it before. Okay, and then we will have to go to from this baseband rate to 48 kilohertz, which is audio frequency. And of course, we put also audio output. Audio device writer. Connect it here. Save. And also, it could be well that I put baseband rate into some init script, because otherwise it will be forgotten. So I go to the modeling and in model settings, model properties, put in some callbacks. For example, preload function. Put this here. And then when you open the model, it will run this script and then create this variable, and then it will be fine. Theoretically, that's it. Maybe we could add spectrum analyzer to be maximally similar with GNU Radio. I will go and find spectrum analyzer, but not from the audio toolbox. Be aware of this spectrum analyzer. Go here and select this. We connect again it to the output of the Pluto. Little bit ugly, but okay. Okay, I will also activate names for all blocks. Okay. Just formats on, and then it will give you name. Maybe it will help you somehow. And here also we must check a little bit, because sometimes there is some weird settings. Actually, I do not like this filter bank, better Welch. Resolution bandwidth. We could use something like 1 kilohertz. Completely enough. Window options. Okay, it could be everything fine. What else you should do? Also put the simulation to infinity. Here, inf means infinity, otherwise it will stop after 10 seconds and you will start to wonder what happened, but it will just because you have limited simulation time to the 10 seconds. By default, it just lasts just 10 seconds. We are ready to run. I will save and run. Okay, there is some problems with dimensions, because this number is not dividable by 11. Yes, because we have decimation 11 times, because we go from 528 to 48. This is 11, and 20,000 is not dividable by 11. So what I do here, I put some number which is divisible by 11, and easiest what I can imagine is 22,000. This is for sure is divisible for 11, because it's exactly, I think, 2,000. Access denied. Cool. This is very, very funny message, because I'm with MATLAB in some bad folder, in bin folder. So I go to my desktop. This is one of the weird things in MATLAB, what I do not like, because it selects some random folder for unknown reason and tries to write everything to this random folder. As a result, usually we have a lot of MATLAB mess everywhere, because we do not control it, which folder it starts. It has some kind of unpredictable feature here. So I go to C, now I go to users, I find myself and find my desktop and models. Maybe here all the trash will be put when it runs, because when it runs, it creates a lot of temporary files and also model itself. And it's also good idea to have this accelerator mode because it will run faster. And in sample rate converter, it must be code generation. Okay, it's already here. It will take time to compile, but then it becomes much faster. And no any dropouts or anything due to the processor overload or something like this. So what I missed? It's fine. It's fine. Okay. Maybe the gain is not good. It's too big or too small.
Also, the video is very distorted.
Very distorted sound?
Video, sound is clear.
Okay. I think it's because some bandwidth problems or internet or I don't
Maybe it
know.
will be fine in recording. But here we can't see anything.
It's just very blurry.
Yes, we can't read.
Oh, very strange. Because I see perfectly, but I think this is because of some zoom problems, because or processor overload or anything
I
else.
used a slider, but and used a variable in center frequency named FC, but I got some error.
Okay.
So what will we give in this sample rate converter?
In the sample rate converter, we convert from this.
FC.
No. We do not have any variable FCS at all in this model.
No, but I used variable in center frequency for the ranger to work, slider to work.
Yes, but slider is not connected to sample rate converter.
Okay, so what will we give the frequency? That input frequency in sample rate?
It will be this, we are converting from the baseband rate, and baseband rate is, in my case, 528 kilohertz.
So we can give 5 to 8, right?
Yes, kilohertz.
Okay.
Yes, it's very strange. Now it even cannot stop. That it has hanged up and starting. Okay, MATLAB encounter internal problem and needs to close. Okay, very good. MATLAB crashed. Okay, now it goes to this again, to this, I don't know, program files. Wow. Okay. Open this model back. Hopefully it will not crash, but well, this is, let's see, this is very poor software. All the drivers and all this kind of totally untrustable, and that's why I even do not trust any of these electronic and computing devices. They are somewhat, they are somewhat flawed, I think. So do you see, or it's still blurred a lot?
Now it's clear somewhat.
Okay, so you see this is sample, Pluto has this is FC here, yeah, but I put here concrete frequency, and here
Now
is a
I am
baseband
getting a
rate, which is
spectrum.
variable, which is 5 to 8,000. And gain, okay, I will use some automatic because I haven't.
Now I am getting a spectrum.
Oh, that's good. Maybe you will have a sound if you had the headphones.
I am using 102.6 megahertz. When you run the model, we can't hear anything you speak.
Because of the sound?
Yes. It was
Okay.
the same problem before also. If you run the model, we can't hear anything what you speak.
It's totally silent or it's
No,
barely
it's
hearable?
static noise.
Okay. And that means when I share, yes, because share sound means that maybe it masks this audio, it doesn't mix at all. Okay, I have switched sound sharing off. It's very strange that this is okay. I have to stop at 4 o'clock because I have another meeting, but for me it's a little bit curious why it doesn't work, because it must be fine. Maybe this frequency. Let's change the frequency because there is nice spectrum.
Oh, I used map function instead of conjugate. E raised to u. It's in laboratory manual.
Oh, MATLAB crashed again. Total shit. Oh. Ah, come on. So I soon will install the Linux here. I feel that I soon delete Windows and install Linux on this machine because it's so steadily badly working. So if it will crash once more, I will stop. Okay, it has some problems. This Pluto driver is failing, I think. Okay, let's use normal. Okay, there is no peak. You see, this is no station. And if I put 92.4, it has a huge station, but why I do not hear any sound? Someone muted? Okay. I think it's dealing with this remote access software, which is somehow okay. If I switch off the streaming and use local sound, what will happen? Yeah, it seems like okay, but it's mostly working, yes, and I think it's because it sends to some kind of wrong audio device. Speakers. Master volume. Okay, this is a display link, real tech. Okay, I have another meeting. So guys, next time we will finish. You will finish this, but it mostly working. So for today, that's all. See you next week. Bye-bye.
Thank you,
Goodbye.
Professor. Bye. Thank you, Professor.
Okay.